This is the video notes for 9.28 Introduction to Scatter Plots, line of best fit. The first page of these notes have us write the slope-intercept form equation of the trend line or line of best fit for each scatter plot. Now a scatter plot is a graph where we just have points, and a line of best fit is a line that we've drawn to try to fit as many of the points as possible. So basically the line is drawn through the middle of the points and as best as we can do. Let's go ahead and write a few equations. When you do equations for lines of best fit, you're just trying to write the best equation that you can. It's going to be in slope-intercept form, so we write y equals, and then we need to find the slope and the y-intercept. So let's look at this first one. I'm going to zoom in here. It looks like the y-intercept is something a little bit more than 9. And then I have a really good point here. And let's say a really good point here. Looks like it goes down to, and then right 1, 2, 3, 4, 5, 6, 7. So -2/7. Okay, so our equation is going to be y equals -2/7x plus a little bit more than 9, so like 9.3. Let's try another. So here we have y equals, our y-intercept is going to be maybe 11, so I'm going to write plus 11 at the end. And then our slope, this is a really good point, and this one. So it looks like I go up from 12 to 16, so up 4, and then write 3. So 4/3 as the slope. Here's number 3. Looks like my y-intercept is a little bit less than 5, so maybe like 3. So y equals plus 3. And then this one is a really good point, and this one. So I'm just choosing where it crosses the grid really well. Looks like it goes from 5 to 10, so our rise is up 5, and our run is whatever this is, 1, 2, 3, I think it's 4. Okay, let's look at number 4. On number 4, looks like our y-intercept is a little bit more than 8, maybe like 8.5, so y equals, and positive 8.5 here at the end. And then we're going to have a negative slope. This is a really good point, and maybe this one. So that's like down 1 and right, looks like 2. So -1/2. So as you're doing these, one hint is just to be really careful about the scale. You'll notice that every box on the x-axis is worth half. So that's where I came up with the 2 in the denominator rather than 4. Okay, so just be aware that the scales might be different. It might be going by halves or by 2s. You just have to pay attention. Here's number 5. Looks like my y-intercept will be probably 8. So y equals plus 8. And my slope, that's a really good point in this one. So that's like down 2, right 5. No, not down 2, down 1, because it goes from 7 to 6. So down 1 and then right 5. Okay, let's do number 6. So the y-axis is going by 10s, so I'm going to say y equals, looks like it crosses at 70. So plus 70 at the end. And then a really good point is over here where y is 50 and over here where y is 30. So it looks like it goes down 20 and right 3. So -20/3. So hopefully you're getting the hang of it at this point. Just picking out the y-intercept and the slope, doing the best that we can. Number 7 looks like it's a little bit more than 0. So y equals, and every box in the y-axis is going by 2's. So maybe I'll just say my y-intercept is 1. And then where's some really good places for points? This is a really good one. This is a really good one. So it goes up 1 box for the y-axis, so that's actually up 2. And then right 1, 2, 3, 4 boxes, but 1 box is worth 0.25, so that's actually right one. All right, number 8. Looks like we cross a little bit more than, well, halfway between 28 and 32, so that's 30. So let's do plus 30 at the end. And then let's find some really good points. This one is really good. And maybe this one. So down 2, right, from 28 to 26, and then write something. So -2 over, and this is going to be from 2 to like 4.5. So that's right 2.5, which is kind of weird to have a decimal in your denominator, but whatever. Okay, and here's number 9. Looks like it crosses at 30, so we're going to write y equals plus 30 at the end. And then next to the x, we'll put a slope of, this is a great point, at the y-intercept, and this one. So it goes up 5, 10, 15. And going right goes to 20, so 15 over 20 with the x. Okay, so that's the first page, literally just looking at a line of best fit for a scatter plot and trying to approximate the slope-intercept form equation for it. Let's go ahead and turn to slide 2. On this second slide, we are going to estimate or predict values based on the scatter plot. And as we do this, we're going to be drawing in lines of best fit as best as we can. So remember, half of the data has to be on top, half on the bottom. So we run a line like right through the middle of the data. Okay, it's not a very straight line. Let me do that one more time. Okay, once we've done that, then we'll make our prediction. It looks like what's the value of x when y when x is 6? So x is 6 right here, so it's going to be somewhere here, so maybe 7. That looks like the closest one. All right, let's do another prediction. Predict the value of x when y is 5. So go to where y is 5, right there. I'm going to draw a line of best fit through the data. It's like kind of like that. So I'm thinking it's close to, which one? Not 12. Not maybe 6. So I think maybe 6 will be a good estimate for x right there. Okay. All right, let's try another one. So when y is 32, so like right here-ish, what is x? So the line of best fit will look like this, kind of like halfway in between. So I'm thinking something a little bit more than 20, which the only option it gives us is 23 right there. That seems reasonable. Okay, let's do another prediction. Predict the value of x when y is 20. So let's put in y is 20 right here and draw in a line of best fit. So I'm thinking probably going to be 10. Okay, right here at the end, probably 10. Okay. All right, let's try another one. So we want to predict the value of y when x is 1. So let's put a line where x is 1 right here, and then try to go halfway in between all the data. don't know if that's a great line, but I'm thinking that a good value will be like, it looks like 17 is the closest one, like right here. Okay. All right, let's try 15. Predict the value of x when y is 8. So I'm going to graph a line through y is 8 and then draw in as best I can a line of best fit. It looks like it'll be probably like 1. That looks like a good prediction. All right, just 3 more. Let's try this one, number 16. What's the value of y when x is 5? So here's where x is 5. Drawing a line of best fit, kind of like halfway in between. Looks like it's going to be maybe 7. 7's a little high. 7, 8, 4. Not really happy with any of these choices. So let's just say the one that's closest. Let's just do 7. Okay. Okay, 15 or 17, based on the value of the scatter plot. Based on the scatter plot, predict the value of x when y is 10. So that's right here. Then let's put a line of best fit through it. So like half the data above, half below. So I'm thinking like something like this. So I think a good estimate would probably be 4 right here for x. All right, last one. Based on the scatter plot, predict the value of y when x is 4. So x is 4. And we'll put a line right through 4 for x. And then draw in as best we can a line of best fit through the data. So it looks like a good estimate for y would be, looks like 8 right there. Okay. So this was our introduction to lines of best fit and scatter plots. I hope that was helpful. I wish you luck on your practice.